All right, this is part 2 of the topic 2 quiz review matrices. So we were in the process of doing at the end of the last part, we were in the process of finding E12. So we took column 1, row 2, column 1, row 2, and multiplied them together. So 5 times 0 is 0, 2 times 1 is 2. Added these up, we get 2. So now we know what goes here. Now, you can kind of see a pattern beginning here, okay? Some of you might just decide to say 1 times 0 and then 1 times 1 and 8 times 0 gives me the same number. But I'm going to go ahead and work them all out, okay? There's a lot of different ways that you can do these. So 2, 1. 2, 1 is row 2, which is 1, 8. Column 1, 1, 0. 1 times 1 is 1. 8 times 0 is 0. My answer is 1. So 1 goes here. And then the last one is E22. Row 2, 1, 8. Column 2, 0, 1. 1 times 0 is 0. 8 times 1 is 8. Add them up, and you get an 8, which goes here. So look, when I multiplied by an identity matrix, I ended up the same thing as if I added to a 0 matrix. Okay. All right, let's do JH. Let's see the difference between these two. All right. J is 9726. 9726. And we're going to multiply it by H, which is 2573. All right. And we know 2 by 2, 2 by 2. These two are the same. So we know my answer is also a 2 by 2. All right, so we're going to look up these four again. E11, E12, E21, and E22. All right, let's go. E11. Row 1, 9, 2. Column 1, 2, 5. All right, 9 times 2 is 18. 2 times 5 is 10. Add them up. You get 28. 28. All right, E12. So row 1, 9, 2. Column 2, 7, 3. So we get 27. 2 times 3 is 6. Add them up, you get 33. 33. All right. You get pretty fast at these. Row 2 is 7, 6. Column 1, 2, 5. Sometimes I like to stack them like this because I know this number won't change because look, they both have the same column, but then these are different. So it kind of helps me keep things. So you guys just do it however you feel comfortable doing it. So 7 times 2 is 14. 6 times 5 is 30. Add them up, you get 44. That goes here. And the last one, E22. Row 2 is 7, 6. Column 2 is 7, 3. You get 49 and 18, which is 67. Goes here. Okay, and that's the answer to C. Now, the answer to D, let's see what happens when I multiply them opposite. Let's see how much order really matters. All right, so I'm going to put H first. H is 2, 5, 7, 3 times J, which is 9, 7, 2, 6. All right, we know this is a 2 by 2. 2 by 2. Doesn't mean because we reverse these that it does work. It just so happens with this one, it does. So we know we're dealing with another 2 by 2. So E11, E21, E11, E12. Yeah, it's called rushing. Don't rush. E12, there we go. Then E21 and E22. All right, here we go. E11, column 1, 27. Row 1, 27, column 1, 97. 9 times 2 is 18, 7 times 7 is 49. This is 67. Ooh, we might be going a little backwards here. All right, E12, row 1 is still 27, column 2 is 26. So let's see, we have a 4, 2 times 2 is 4, and 7 times 6 is 42. Now we have, add these up, we have 46. So this is 46. Okay, let's try E21. E21, row 2 is 53. Row 1 is, column 1 is 97. So 9 times is 45. 3 times 7 is 21. Ooh, we have totally different numbers. Oh, that should be a 66. 4 plus 2 is 6. Not 8. 66. That goes here. And then E22, row 2, 53 on the first one. Column 2, 26. 5 times 2 is 10. 3 times 6 is 18. 28 goes here. So the only ones that were the same were these two and these two, but they just switched places. Okay. All right, so please make sure you put them in the correct order so that your matrix is the same. All right, I'm going to skip the challenge for now. I want to make sure you understand everything that's going on. So question 5 says, solve for the unknown variables. So when you have two matrices that are equal to each other, this one goes with this one. Okay? So 8 equals, we're going to write it just like this, 4x. But before you can go, okay, we know this is a 2 by 2 and a 2 by 2, and I'm only going to give you exactly the same matrices when it does this, okay? They have to be the same in order to do this. It also equals another 2 by 2. Okay, this is similar to adding. The dimensions have to be the same. So if we solve this, we're going to divide both sides by 4, because this is called solving. We get 2 equals x. So I know, nope, don't do that. Actually, what we're doing is just solving for the variables. Ignore what I just said. We're not doing this. We're just solving for x. And we did that. Now I'm going to look at this one and solve. This one has a y in it. So let me change colors. I know that this one goes with this one. So I'm going to write it out. -1 equals y plus 3. All right, this is basic algebra. Solving for y. So I'm going to subtract 3 from both sides. And you get y equals -4. That's that answer. Now I have a z. Let's change colors here. Now I have a z. These go together. Oh, wow. I don't have too much to do. Look at this one. Z equals, so -3 equals z. That one's already done for me. I didn't have to do anything. And then let's do the last one. Let me get a different color. trying to have all these different colors. This one goes with this one. So -6 equals 18W. I'm solving for W. So I'm going to divide by 18, which means W equals -1/3. And I found W. So I found X, Y, Z, and W. Those were all the unknown variables in these matrices. All right, let's do B. This is kind of fun. All right, this is easy. This is a 3 by 1, and this is a 3 by 1. They have to be the same to do this. So we're going to set the first one. -9 equals 2x minus 3. So I'm going to add 3 to both sides. -9 plus 3 is -6 equals 2x. That goes away. Divide by 2. And I found x to equal -3. Found x. This one has a y in it. So we're only solving for the variables. So 3y plus 5 equals 20. Solve for y. Subtract 5 from both sides. 3y, that goes away, equals 15. Divide both sides by 3 because these two are multiplying. 3's cancel, just like the 2's canceled here. Then you're left with y equals 5. Now, I don't have to do anything with this bottom one because there's no unknown variable. So we're just going to leave it alone. But it makes perfect sense because if you're solving for the unknown, it should be this equals this, and this equals this, and 3 should equal 3. And it does. All right, let's do C. Again, we're doing the same thing. We're just practicing. So we have 1/2 x minus 8 equals 10. All right, so I'm going to add 8 to both sides first. Always do my addition and subtraction in algebra first. And I'm left with 1/2 x equals 18. To get rid of this fraction, I'm going to go ahead and multiply both sides by 2 because this goes away and I'm left with x equals, and 18 times 2 is 36. Okay? All right, let's try the next one. 4y plus 6 equals y. Oh, I have y's on both sides. Well, I want my variables on one side and my numbers on the other. So because my variable is all alone here, I'm going to move this variable up to join it. So the opposite of 4y is -4y. And then I'm going to subtract 4y. So then I have, that goes away, and I'm left with 6 equals 1y minus 4y is -3y. Divide both sides by -3. So they cancel out, and I'm left with y equals -2. Now, you can always check and make sure these work, because if I took -2 and plugged it in for y, whatever's on this side should equal this side. So -2 times 4 is -8, and -8 plus 6 equals -2. So I know I got the right answer. All right, the last one. 7z minus 9 equals 13. I'm going to add 9. I get 7z equals 3 and 9, is 22. Divide by 7, this is a terrible one. So I get z equals 22/7. That's correct, because if I stuck it back in here, I would get the right answer. All right, we're going on to part 3.